Hello Nandal, I'm Brian Balaji from ECE branch. Today my case study topic is applications of Coulomb's law in powder coating presented by Ryan Balaji, Sadhana Harikrishna, Sanjaya Karapuswamy. Index Coulomb's law powder coating, charging power particles, powder dissipation and layer formation. Powder coating it's not just for motorcycle. What is Coulomb's law applications for? Applications of Coulomb's law, limitations of Coulomb's law, example. Here is the man, Coulomb's law, the man, Charles Augustin D. Coulomb. Powder coating. The object that is to be coated is negatively charged by grounding it with the help of a wire. The Coulomb's force of attraction existing between the coulombs. The Coulomb's force of attraction existing between the positively charged power and the negatively charged object allows the paint to get evenly dissipated on the surface of the object. Introduction: Coulomb's law. Coulomb's law is a law of physics describing the electrostatic interaction between electrical charged particles. It was studied and first published in 1783 by French scientist Charles Augustin de Coulomb and was essential for the development of the theory of electromagnetism. It deals with the force a point charge exerts on another point charge. A point charge means a charge that is located on a body whose dimensions are much smaller than other relevant dimensions. For example, a collection of electric charges on a pinhead can be regarded as a point charge. Charges are generally measured in coulombs C, and coulombs is approximately equivalent to 6 into 10 to the power of 18 electrons. It is a very large unit of charge because electronic charge E is equal to minus 1.6019 into 10 to the power of 19 C. Coulomb's law states that the force between 2 point charges Q1 and Q2 is along the line joining them directly proportional to the product Q1 Q2 of the charge, inversely proportional to the square of the R between them. Expressed mathematically, F is equal to K Q1 Q2 by R square. Here K is the electric force constant. Powder coating. Powder coating is one of the applications for Coulomb's law. Powder coating is a mixture of polyester and pigments. A powder is placed in the spray gun and it is positively charged with the help of an electromagnetic coil. The object that is to be coated is negatively charged by grounding it with the help of a wire. The Coulomb force of attraction existing between the positively charged powder and the negatively charged object allows the paint to get evenly dissipated on the surface of the object. It is most commonly used in automobiles industries and for other commercial applications. There are always free electrons or ion present in the air. If an electron passes through a strong electric field, it will start moving in this field along the field lines and be accelerated by the field force. As an electron accelerated along the field lines, it will ultimately run into air molecules. See the figure. If the field strength is fluctuated and the electron has been gathered sufficient kinetic energy while traveling along a field lines, its impact on the air molecules will be strong enough to split that molecules to form two secondary electrons and one positive ion. The remainder of the molecules, secondary electrons will instantaneously be accelerated in the electric field. Moving along the field lines, they will split new molecules and create more ions and electrons. Charging powder particles. In this figure, illustrate a powder particles in electric field. The uncharged dielectric particles will distort the external electric field so that some field lines will extend towards the particle surface, enter at a 90 degrees angle, pass through it. The exact at a 90 degrees angle. If free ions are present in the external electric field, they will follow field lines towards the uncharged particles and ultimately be captured by the picture field of polarization 2, thus increasing the particles' own charges. This process will continue until the charge accumulated on the particles as a result of capturing multiple ions is sufficient to create the particles' own electric field. This field will again charge the agent of the external field lines. This time, the external field lines will be pushed away from the particles. You can you can see in this figure. When this happens, ions from the external field can no longer reaches the particle because its own field repels them. In other words, the particle has reached maximum charge gain. The external field strength, particle size, and material. Powder dissipation and layer formation. In this given figure, force affecting a charged power particles as it travels from the spray gun to the grounded part. It should be noted, however, that the only force pushing the particle towards the grounded subtractor is the electric force equal to the charge of the particle multiplied by the strength of the electric field. The air stream delivers a particle to the part. However, if the particle is not charged or field strength is not sufficient, the particle will bounce off the metal subtractor and either be carried away by the air stream or fall down under gravity force. The electric field helps the particle come over aerodynamic and gravity force and remain on the part surface to allow yet another force to be established. This new force is the attraction between the charged particles and grounded metal surfaces. Powder coating, it's not just for motorcycle. Another use of electrostatic process is electrostatic painting or coating is also known as a powder coating. This process uses a high voltage electrostatic charge which is applied to both the object to be coated and the spraying mechanism. A coating of either powder particles or an atomized liquid is accelerated towards the workpiece by a powerful electrostatic charge. The ionic bond. What is Coulomb's law applications for? Coulomb's law is applicable only for point charges. This is because if two charged bodies are taken at any r distance, Coulomb's law is applicable only for the point charge. This is because if two charged bodies are taken at any r distance, they will definitely induce an opposite charge on the other body. These would considerable affect by the net charge on the other body as well as the distance between them. That is, some charge will be attracted and those come to the front face of the body, while the other will be repelled and, and those it will move to the far end of the body. And as well as known, F depends upon Q as well as R. But for high school mathematics and physics, we take the relevant distance between two bodies so large that the actual size and shape of the body can be neglected and they can simply be treated as a point charge, making Coulomb's law applicable. Applications of Coulomb's law. It can be used to calculate the force between two charges. It can be used to calculate the distance between two charges. It can be used to calculate the charge of any immediate process. Initiate provided F and R are known as for the two charger systems. The law has been employed for determination of velocity, momentum, energy, etc. for an electron in an orbit by Bohr. It can be employed for calculation of electrostatic potential energy and hence potential difference. It can be used to calculate the relevant permeability of a maximum medium, etc. Limitations of Coulomb's law. Coulomb's law is derived under certain assumptions and can't be used freely like other general formulas. The law is limited to follow points. You can use the formula if the charges are static in rest position. The formula is easy to use while dealing with charges of regular and smooth shape and it becomes too complex to deal with charges having regular shapes. The formula is only valid when the solvent molecules between the particles are sufficiently large than both the charges.
Examples: mixing substance in water, Xerox machine, charger rod, balloon sticking to wall, Thomson bites of paper, powder coating, electrostatic air cleaning, starter from an aluminum plate. Thank you.